Hello, ladies and gentlemen. So, we want to continue the theory of logarithms. Okay, so we have other questions that we need to touch base with. Okay, so that we can get a full clarity of what theory of logarithm is all about. So the same thing applies. I wrote down some questions for part one. So we've been able to solve like two. So we wanted to solve the other part for this part two. So for number three, which is log half base 8, find the value. So what you just need to do, let's follow the normal process. Log half base 8 equals, let me just say, x. Okay, so like I said, from equation 2. So in a normal exam, you might not need this. Just write the whatever straight. Just write the law straight based on this equation 2. You might not need it. But if you want to write it, it's okay. But if it's an objective question, you don't need it. You know what to write. Just go straight to the point. So it means that my n here is half. Okay, it's half equals 8 raised to power what? X. Okay, my a is 8, my y is what? X. So from here, from negative index law under indices, this is 2 raised to power minus 1 equals, how many times will I multiply 2 to give me 8? 2 times 2, 4, 4 times 2, 8. That is 2 raised to power what? 3 into what? X. So this one, that implies you have 2 raised to power minus 1 equals 2 raised to power 3x. Okay, so from here now, I can now cancel the base. Since they have the same base, I can cancel it in exponential function under indices. So that is the last part I treated under indices. It's very simple and straightforward. So I can cancel this base and bring down the power. So this is minus 1 equals what? 3x. So by the time for you to get x, you divide both sides by the value beside x, which is 3. So when you divide both sides by 3, you divide it by 3. So that implies that your x equals what? Minus 1 over 3. You now say, therefore, log half base 8 equals what? Minus 1 over 3. It's as simple as that. So you can see that it's not hard. It's just straightforward. So, and I believe it's clear since we've done two. We've also done something on this too. So number 3 is cleared. I'm cleaning it so that we can do number 4. We can solve number 4 rather. So that is for example 3 has been done. So we move to number 4. Number 4 here says we have log 4 root 2 base 2. So we should find the value of log 4 root 2 base 2. Follow the same process. Let log 4 root 2 base 2 equals, let me just say IJKLM, let me just say n. Okay, so that implies from equation 2, that's 4 root 2 equals 2 raised to power n. So what comes in your mind? How do I make my base to be equal to this base? So it will now be 4 times 2 raised to power half. Don't forget, equals 2 raised to power n. So don't forget that, I've told you, square root, we have root law under indices. So the square root is the same thing as raised to power half. And that is exactly what I've done here. So, and don't forget, 4 is also the same thing as 2 times 2, which is 2 raised to power what? 2 times 2 raised to power what? Half equals 2 raised to power n. And in law of indices, pick one base and add the power for multiplication law. Okay, which is 2 plus 1 over 2 equals 2 raised to power what? N. It's as simple as that. Now we now have the same base. So what do? You cancel the base, you bring down the power. So from the LCM, this is 2 raised to power 1, you can find LCM here. So from here you can have 2. Okay, 2 in 1 means 2 divided by 1 is 2. 2 times 2 is what? 4. The same thing applies here. 2 in 2 will give what? 1. 1 times 1 will give me what? 1, which is equals to what? N. So this is the same thing as what? That implies that you have n equals what? 5 over 2. It's as simple as that. So you can now conclude and tell the examiner, or perhaps if it's objective, just go straight to your answer and pick your answer. Or if it is theory, or perhaps it's something you need to show your work in the class for your teacher to mark. If you're in SS1 or SS2 or SS3, okay, then you need to conclude and tell your teacher that therefore the value of log 4 root 2 base 2, log 4 root 2 base 2 is equals to what? 5 over 2. It's as simple as that. So don't forget LCM. You take the LCM here, it's 2. 2 in 1 will give you 2. 2 times 2 is 4. 2 in 2 will give you 1. 1 times 1 is what? 1. So it means that at the end of the day, your n is equals to 5 over 2. It's as simple as that. It's straightforward. So let's quickly move to question 5. So we have number 5 that we need to solve now. So that number 5 says that we should find the value of y. Okay, so it means that we have that's log y base 25 equals what? Half. So that implies from equation 2, your y equals 25 raised to power what? Half. It's as simple as that. Your y equals what? 25 raised to power half. So it means your y root law indices is the same thing as square root of what? 25. And your y is equals to what? 5 times 5 is what? 25. It's as simple as that. So it does not, you don't need to stress yourself. That is why you need to understand the theory of logarithm. Okay, logarithm. You need to understand that theory. That okay, if you have log number of n to base a equals y, it's the same thing as saying n equals what? A raised to power what? Y. So the answer is straightforward. So the answer, it means that my y is equals to what? 5. That is the beauty of you understanding the basic, the fundamental under theory of logarithms. Okay, so now the last but not the least, which is number 6 here, is log m base 5 equals what? Minus 2. Okay, and the question says we should find m. So that implies from equation 2 again, m equals what? 5 raised to power minus 2. Okay, from indices, okay, I can remove the minus. I can, as in to remove the minus is the same thing as saying 1 all over 5 raised to power what? 2, which implies that m is equals to what? 1 over 5 times 5 is what? 25. That is just the answer. You can see that this particular theory, this illustration we use above here is very key for you to understand. Log n base a is equals to 5, and is the same thing as saying n, which is number, is representing number, equals to what? A raised to power what? Y. Is very key for you to have that at the back of your mind. So in case you meet this kind of question in anywhere, any in your exam or your school exam or in the objective, just quickly go straight to the apply the the theory law, and then go straight and get the answer out. So it's as simple as that. So in our next part, so what I'm trying to do now is that some of the questions we've shared that we stopped at question 14, if I'm not mistaken. So we'll still be touching base with those questions while we also continue with laws of logarithm. So that we can balance the old process, the old teaching process. So now we'll move to laws of logarithm, and we'll solve questions under each laws, so that by the time we dive deep into past questions or questions that have come out in the past, then we'll be able to flow along and then understand them and be able to solve them. Thank you very much. Continue to like, continue to share, continue to comment, okay, and then so that we can reach a lot of young minds. Thank you. Cheers. Bye.